All right, class. Now let us start with the revision of nuclei. So nuclei and semiconductors are left now. Then after that, we'll start with again proper revision based on your exact pattern that has to come, MCQs involving. All right, these were just the questions, basic questions from previous years that have repeated themselves. So today also let us try to complete at least semiconductors and nuclei. So nuclei is a very small lesson. In nuclei, you just have to remember nucleons are protons and neutrons collectively called. Atomic number is represented by Z. Mass number is total mass of number of protons and neutrons. So from here, this part you have to remember these three. I have told all of you to remember this because in many questions this is not given, and sometimes it can be asked to you to remember and write it. Then you have to write about the nuclear size. In nuclear size, volume of nucleus is directly proportional to the mass number. So 4/3 pi r cube. 4/3 pi r cube is directly proportional to mass number. So from here, r cube is directly proportional to a. So finally, the result is r is equal to r naught a to the power 1/3. A here is the mass number, r is the radius of nuclei, r naught is 1.2 Fermi meters. All right. So we had seen a question also where this R naught was given as 1.1 Fermi meter. So whatever R naught's value is given, you'll choose it. But this is an important relation because now nuclei has only 2 to 3 topics and those can only come. So every topic in nuclei now becomes important. Otherwise, we used to say radioactivity was an important proportion. From that also, plus beta minus beta decay was important like this. Now this is just 2 to 3 points are there. So remember it. This is one part that involves nuclear density and nuclear size. In nuclear density also, remember just how to derive this and finally remember the resultant answer. Just put all the values and show 2.3 into 10 to the power 17 kg per meter cube is coming. And whatever material is given, iron and all, like this was a question. This among this also one of was from previous year only. I don't remember which one. This one was from previous year. And one more question. I think this water one. Two questions were from previous year only. Then second topic that was important was mass defect. How do we calculate mass defect? Total number of total mass of protons we calculate. So mass of single proton is MP. Mass of single proton is MP. Z number of protons are there. So total mass becomes ZMP. Similarly, mass of a neutron is Mn. Total mass number of neutrons is A minus Z. So that becomes A minus ZMN. So total mass of nucleons means proton plus neutrons. It will become ZMP plus A minus ZMN. Subtract it from the mass of nucleus, you get the mass defect. And if you multiply it by C square, you get binding energy. Divide binding energy by mass number, you get binding energy per nucleon. Or best way is to multiply it by 931 to get the resultant answer. And finally, you have the binding energy curve. This is not very important, but just read the theory parts once. I think nuclear fission, nuclear fusion, all these points have been already mentioned in the notes. So I hope all of you have gone through the notes once. And class, one more thing. In the notes, most of the questions, most of the topics have been covered. There are some extra topics as well. Like in semiconductors, you will find Davison and Germer's experiment completely written. In nuclei, you will find radioactivity completely explained. So whatever topics I have told you that are coming in the syllabus, just do that only. No need to go through the notes because these notes are actually based on the previous pattern. That's why. All right, so let us just practice few questions from nuclear, then we'll move on to semiconductors. Note down the question, try to answer it. Those who get their answers, write me in the chat box. No, Krishna, check your calculations again. Okay, let me tell you how to calculate these, because in some of the earlier question papers, this type of question has come. This is actually a part of your chemistry. So if it has to come, it can come from the chemistry. Now see how to calculate it. The natural chlorine is found to be a mixture of two isotopes of masses. One is given as 34.98 AMU and other is 36.98 AMU. This is given for both of the chlorine. Now, relative abundances means how much they are present, their quantity, their relative abundances percentage is present, and you have to tell what is the average mass that we take. We take one mass of chlorine. 35 you usually take in your chemistry also. You take it as 35 is the aggregate mass. But 37 is also used somewhere. 35 is the aggregate. Yes, Krishna. Just check the powers once again, I think. Just check the powers once again. Now it is magnitude of the significant figure is better. Just check the powers once again. So in such questions, how do you calculate? To find out the mass of the chlorine atom, take the relative abundance and multiply it by the mass. Like relative abundance is 75.4 multiplied by 34.98. Then add the next one, 24.6 multiplied by 36.98, and divide the entire term by the total percentage, or directly divide it by 100. Directly divided by 100. So when you solve this, this will be around 2637.49. This will be around 909.71 divided by 100. So your answer, since I remember the answer, and we all remember the answer for this, so you can remember, directly write it as 35.47. And for the second question, equivalent energy, E is equal to mc square. I have told you we do this question and we solve this part from in dual nature portion. But usually the weightage is included in nuclei. So the questions will be from nuclei only. Mass is 10 into 10 to the power minus 3 c square, 3 into 10 to the power 8 whole square. So 10 into 10 to the power minus 3 into 9 into 10 to the power 16. Right, so 16, 3, 13. This you're getting as 13, 14. 9 into, how much you were getting, Krishna? 9 into 10 to the power 11. I think the answer is something. Let me just check the answer first.
Ma'am, milligram to kg, right?
Okay. Yes. Milligram to kgs. This is milligram. No, we have to convert it into kgs. So in that case, minus 3, 9. It will be 9, no? 10 to the power 9. Let me just check the answer. Just a second. Final answer is 9 into 10 to the power 9. And what are we getting? minus 3. So that makes it minus 6. So minus 10, 1 minus 10, that is 9. Now 10 minus 1, this will be 9 joules. No. See here, minus 3 we have into 10 to the power minus 3. So 16 minus 6, that, okay, no, 11 it will be. So I think the answer must be wrong because Krishna, you are also getting 11 only. And see, this is 10 plus 1 will be here 11 only. Answer is given this. I think the answer will be wrong. It should be 9 into 10 to the power 11 only. It actually came a long time back, 1992 question from your board exams. Note it down. Let's see some more questions that have come from this part. Okay, okay, Salman. Fine, fine. Atif and Krishna, you both are getting 940 or 930 mega electron volt. Just check again your calculations. You have to calculate equivalent energy of 1/12 of mass of one atom of carbon 12. Mass of one atom of carbon 12. One single atom. One atom. So 12 AMU that we write, I hope you're not just using that. Convert it into kg. AMU, convert AMU into kg, atomic mass unit. Others also, see what answers you're getting. Krishna, Memuna, Priya Darshini, Sara. Calculate the energy equivalent in mega electron volt of 1/12 of mass of one atom of carbon 12. See, mass of one atom of carbon 12. This is 12 AMU, but we have to convert it into kgs for our calculation. So when you'll convert this into kg, because AMU we cannot use it directly, no. So 12 into an atomic mass unit is 1.66 into 10 to the power minus 27 kg. Now E is equal to mc square. Use this. Mass is 12 into 1.66 into 10 to the power minus 27. C square. This will be 3 into 10 to the power 8 whole square. Then we have to find it in mega electron volt, no? So let us divide it by 1.6 into 10 to the power minus 30. Now tell me what is the answer coming. Is it still coming 930 or 940 what you people were getting? If same method you have applied. Tell me what's the answer that is coming. See, this will almost get cancelled.
Ma'am, it's 1/12 of the mass of one atom of carbon 12, right?
Yes.
My question says 1/12, so it will be one atomic mass in it, right?
No, 1/12 of mass of one atom carbon 12. See, mass of one atom, we have to find it out. When you are calculating 1/12 of mass of one atom, no, when it is written 1/12, that means we are referring to one carbon atomic mass unit, which you're saying. It is saying 1/12 of mass of one atom of carbon 12. When the entire statement is written, no, complete 1/12 of mass of one atom of carbon. So in one atom, we have to consider all that it is included, means 12 atomic unit. See, 1 AMU, you're saying this, no? 1 AMU is 1/12 the mass of carbon 12. Right, you're saying this, no? So see, even when you are calculating the same thing, this is same thing. How? This is 1 AMU, 1/12 of carbon 12. So multiply it here. 12 AMU will be mass of the carbon 12. Now for converting AMU, you'll multiply it by 1.66 into 10 to the power minus 12. So I think when you solve this, you should, because this value, we usually remember it 1.992 into 10 to the power minus 26 kg. Because this gets used a lot in chemistry, no? So this value also. So 1 AMU is 1/12. So same thing, just multiply 12 AMU will be 12 into 1.996. 1/12 mass of, because we have to find it for one carbon atom also, no? This is 1/12. So for 1, you have to multiply 12 here. Understood the point?
Yes.
Okay. So see here, the answer would be around 108 mega electron volt something. 11205 mega electron volt. Around this, the answer should come. So those who have done and tried the first part, try to do this question, second question. This is also a question that has repeated itself. Once it came in 2000 and 2006. Answer both the parts. These are theory questions. Class, try to answer this. Few statements just you have to write. Okay, Krishna has answered both the parts. Yes. Good, Krishna. Very good. And Sarah has also answered. First part you have answered. No, correct. C. Yes, they are isotopes. Look at the elements. Can you see anything common in between them? Obviously, you can notice. Same atomic number. Z is equal to 3. Same atomic number. That's why they are isotopes. This is the answer for the first part. And second part, just a second. Huh. So see in the second part. In the second part, it is asking which is more stable. See, when you take out the difference between both of these, isotope that is X73, this is having 3 protons and 4 neutrons. X is having 3 protons and 4 neutrons. Right. And regarding Y has 3 protons and 1 neutrons. Protons will be same, 3, 3. How much is left? This is 4, no? That's 4. So 1 neutron. All right. Now, due to presence of greater number of neutrons, if you notice here, this is greater than this. So more neutrons, more stable. This is the answer for this. I think now just 1 or 2 questions are there which have come in your exam. One was same we did, calculate nuclear density one. That was a previous year question that came in 2004, 2013. We did a question on iron, I think, or some compound. Okay, it came in 2004 and 2013. So that is, and one more question I think is left. 1 or 2 questions only from nuclear. Total questions that have come from the topics that are included. Rest of the questions that have come till now, no, I've started it from 1990 till the last previous question that came. Mainly the questions are from half-life period and radioactivity. So very few questions are there. I think we have almost covered all of it. I think 1 or 2 are left. Let me write it on binding energy. 1 or 2 are left. Okay, Priyadarshini. Question says a heavy nucleus X of mass number A is 240 and binding energy per nucleon is given as 7.6 mega electron volt. This is split into two nearly equal fragments, Y and Z. And the mass of Y and Z both are given, 110 and 130. Binding energy of each of these is 8.5 mega electron volt. You have to find out the total binding energy of all the nuclei X, Y plus Z and the whatever energy will be released. So, and if you have the binding energy of Y, if you have binding energy of Z, if you have binding energy of X, you can easily calculate. See, if this is the binding energy of X, X has been split into Y and Z, right? So if energy is released, it means some gap will be there that we have to calculate. Then only no energy has been released. It means whatever will be the sum of the binding energy of Y and Z. And if you subtract this from the binding energy of X, then you'll get the total heat energy released. So first task is to find out binding energy of X, then Y, then Z. This is how you will do the question. Do you need 1 or 2 minutes more, or shall I discuss this? Yes, class?
2 minutes, ma'am.
Okay, then last 2 minutes. Do it in this way only. Binding energy of Y plus binding energy of Z minus binding energy of X. That will give you heat energy released. Okay, Krishna. Now let's discuss the solution. Others also pay attention. How will we calculate? See, let us just talk about first the nucleus X. The nucleus X. Binding energy per nucleon is given 7.6 mega electron volt, right? So total binding energy will be, and atomic, the mass number we know, this is 240. So total binding energy of X, this will be 240 multiplied by 7.6 mega electron volt. So this will be how much? 240, 0, 4. Then 112, 2, 1, 18, so 8, 2, 2824, right? 12, 14, 1, it should be 1. 1824. So 1824 mega electron volt. This is binding energy of X. So this is 1824. Then come to nucleus Y. A is 110. Binding energy per nucleon is, how much it was given? 8.5, no, each. Okay. 8.5 mega electron volt. So total binding energy for this will be 8.5 into 110. So this will become 5.0, then 3, 935 mega electron volt. This is for nucleus Y. Same thing, nucleus Z. A is different. A is 130 and this is binding energy was given same, no? Binding energy per nucleon is still 8.5. So total binding energy will be 8.5 into 130. This will be again 5, 15, then you have 20. So 0, 1 mega electron. Now CQ will be Y plus Z minus X, 935 plus 1105 minus 1824. It came, no? 1824. This will be 10, 314. Then 9, 1 again. You have 10 and 1 plus 1, 2. Minus 1824. Minus 1824. This will be 6, 206 mega. Note down it, class. See, let's start with semiconductors. One question at least, let us discuss it. Just this portion. Rest of the part we'll complete on Monday now, whatever is left in semiconductors. So see, Ne is number density of electrons, NH is number density of holes, and Ni is number density of intrinsic semiconductors. So in extrinsic semiconductors, you have two types of semiconductors, P-type and N-type. That all we'll see in the next class, all the doping part of it. Just understand the extrinsic and intrinsic semiconductor basics. This relation, because we didn't do any question on this. So let us practice this on this question, based on this equation. At least class, try to answer all the parts of this question. It's a very easy question. The equation also for the second part, I have told you which equation has to be used. At least try it. Sara, Memuna, Krishna, Atif, answer quickly. Okay, so only Atif has answered and all the parts are correct. Good, Atif. Very good. See, electron concentration is increasing. Number of electrons is where? In which type of semiconductor class? Except Atif, nobody knows this. Where are the electrons majority charge carriers? Where is the number of electron more? Good, Memuna. Yes. First, second parts, both are correct. N type, no class. Shara and Krishna. Agreed or not? Right? Electron
Yes, ma'am.
concentration is more. So it is N type. Now you have to find out new hole concentration. So this relation Ne into NH is equal to Ni square. Ne is given. Ni is given. Where electron and hole are equal, it means this is intrinsic. Right, this is intrinsic. This is a very basic question, class, because most of the questions are based on this pattern. Most of the questions. This is just one type that I have taken from 2005. Two questions, one was there in 2007 and one in 2001 was exactly like this with just the numerical difference. So this is a very easy question. You all should be able to answer this. So NH will be Ni square. That is 6 into 10 to the power 8 whole square divided by Ne, that is 9 into 10 to the power 12. So this will be direct 4 into 10 to the power 4 per meter cube. And how does energy gap keep varying? See, energy gap decreases with doping. Energy gap decreases with doping. Reason is that the impurities keep on getting added. No, so that disturbs the energy equilibrium. All right, note it down. All those who have not written, text me done. Then I'll continue the rest of the lesson in the next class. And after that, on Monday, we'll finish off with semiconductors. Now, very few questions are left. Some important question. Most of the questions we have completed from all the lessons. Some important questions are there from every lesson, including certain MCQs, because I haven't done a single MCQ with you all, including MCQs also that we'll do after Monday. And if you have any doubt portion, any particular part that you're not able to understand, like let's talk about semiconductors. Let's say someone has doubt in rectifiers or any topic from any of the lessons. So please either text me on WhatsApp prior to the class or in between the class, tell me while we are revising. And keep on practicing more and more of questions. You will be getting your marks also soon. Of physics test was, I think, not given in your test. That is also left. Chemistry and bio, I think rest of the subjects you have received. So if you have all have completed, you all can leave now. Thank you so much, class. Thank you. Goodbye.
Thank you, ma'am.
Thank you.